I want to do today is that there were one portion which I couldn't cover last time, so I will cover that first actually. And just to give you the glimpse of how different areas, people have got a feeling that computer science is a holy cow. Unfortunately, it is not so. Actually, every walk of life you will find that either computer or computer programming is touching you. If you go to the bank, you go to the post office, you go to administrative offices, you go to a manufacturing facility, you go to a hospital, you go to a restaurant even, you will find that there is a role of now computer. It is almost pervading all walks of life. Obviously that we can cover all of it, but I am going to give you two examples today which indicates how wide and how interesting the applied area of computer science is. Actually, there are three divisions of computer science as we call. First one is the theoretical computer science. I explained to you some of the things of the mathematical background that is required. In fact, sometimes the computer science department is a part of mathematics in some universities. The second one is what we call as the systems engineering. Last time we talked about the compilers, operating systems and so on. Those are the programs, those are the systems called as the systems engineering. And that is where a lot of people, like for instance the Microsoft company is a systems engineering software company. But then there are various other areas like artificial intelligence, computer graphics, computer aided design, geometric modeling, robotics. These are some of the areas which are kind of applied areas of computer science, and many departments have this as a part of the computer science department. These are truly interdisciplinary areas. About 35 years back, when I was starting my academic career, my passion was on graphics. Anything which you can describe in pictures, I always like it. And as they say, that one picture is equivalent to 1,000 words actually. So it's always very interesting to express in the form of pictures. Unfortunate part is that all of us are not Picassos, all of us are not Raja Ravi Verma, and so our ability to draw by hand varies from person to person. Now that is the fortunate part of computer graphics, because you will find in computer graphics now you can give the instructions, you can write a program called as a graphics program, and then the program runs it and gives you the picture. And some of the fascinating pictures on computer graphics are being done by the computer scientists, and now they call themselves as the computer artists. And so you will find variety of things. For instance, if you look at the top left here, now this is a picture of something like a mountains and valley and the greenery, etc. Now one may think that this is a photograph, or one may think that this is something like a painting that has been done. And to your surprise, it is neither of them. Okay. In mathematics, there is a term called fractals. I don't know how many of you are familiar with the fractals. Now if I take an area and if I keep on subdividing it, and for each subdivision I keep on further in the recursive manner that I mentioned to you, and if for the small little triangles that I have, if I change the shades of them, I can create a scene like that. Okay. So what I have shown here on the top is not a painting, it is not a photograph, it is a computer generated picture using mathematical model of fractals. So by changing the seeds, you can change the scene. I can show you the Grand Canyon, I can show you the Sahyadris, I can show you the sea, I can show you many things. Actually, there is a person by the name Mandelbrot. Mandelbrot was a mathematician, and then he became computer scientist. And what Mandelbrot developed was this theory of fractals. But in order to convince people that this theory of fractals is very important, what he did was took recourse to graphics, and there is a book by Mandelbrot which is fascinating pictures. If you see those pictures, you feel as if it is like the photographs of some natural surroundings, but they are not the photographs, they are basically computer program outputs based on the fractal model. And that is one of them that I have shown to you there. The second picture is also very important. When we started computer graphics work, originally, as you must have seen in AutoCAD, drawing a line itself was a big thing actually. Then people started working on what is called as the raster graphics. And then the question came of shading. For instance, if you have got a surface and you want to shade it, how do you do it as a logic of the computer program? If you want to show that as if this particular object, if it is a building or something like that, and you want to show it as an outside, you want to show the shadow. Now how to show the shadow, how to do the shading of the curved surfaces, how to use the color. Unfortunately, in the beginning when we had monochrome terminals, we could not show you the color. But now most of the devices, the display devices, whether it is a television or whether it is a computer screen, you will find that it is all in color. And today you will find that the palette of colors is millions of shades that you have. In fact, if you are a painter and if you have a palette, you will find the amount of options that you have is very, very limited. Compared to that, if you are a computer programmer, a computer graphics programmer, you have got millions of shades that you can use for the purpose. There was a group of computer graphics at the University of Utah. In fact, this picture is a very famous picture called as the University of Utah teapot. What they did was they took this as an example for all the research that they did related to shading, shadows, colorimetry, etc. They used this particular picture, and this is a very famous picture which shows how the shadow, as you can see clearly that this particular teapot, there are two bulbs, two light sources. As you can see, there are two shadows, one on the right hand side, one on the left hand side. So clearly it shows that there were two light sources. Now the combined effect of these two light sources on that curved surface shows the you can say the shining part or the dark part, and that gives you the impression of the curved surface. So all the things that are required for the artist to understand, we have incorporated them. But all the things the artist does by hand, we have taken care of it through a computer program. So that is the fascinating part of computer graphics, that you can do all the imagery through programming. So this is one area which I thought I will explain to you, that this is something which is very fascinating, and I have shown you only the still pictures. Things have moved further, and not only you can have a static picture or an object which is static, but you can also take care of motion. As you can program the graphics, as you can program the geometry, you can also program the motion. And that is the area of robotics which I will introduce to you. So the first thing that I want to mention here is that the major classification in computer graphics is vector graphics and raster graphics. Vector graphics was like, if you look at the CRT, the cathode ray tube, which had got two pair of plates, one along the horizontal axis and one along the vertical. So there is an electron beam which is coming out, and the beam can be deflected this way or the beam can be deflected this way using the electrostatic potential on these pair of plates. So if I change the voltage impressed upon this vertical, then the beam will go up and down. If I change the voltage pressed upon these two parallel plates, the beam will deflect. So by controlling the voltage, I could control whether I want to draw a line, whether I want to draw a circle. All it is called as vector graphics. Okay. There was another development. As you can see in the television, what pictures you see, they are not like this what I explained to you. In television, what is happening is there is a raster, there is a scan, so the line by line the scanning happens, and if sometimes the television is not working, you will find you can see those lines in a very haphazard manner. So this line by line scanning, and if the scanning happens more than 30 times a second, your eye will not detect the difference. If I keep on scanning very fast, you feel as if it is a static picture or it is a stationary picture. So using these two aspects, you will find enormous development. Today, whatever pictures you see, whatever pictures I have drawn over here, they are through raster graphics. So dominant mode of graphics displays is raster graphics. Then earlier pictures, as I said, were monochrome, that whatever is the CRT tube, the electron beam, it could be greenish or it could be bluish, but it will be all in one color. Today that is not the case. You have got RGB. So in the good old CRT, instead of one gun, they used to have three guns, R, G and B. And the guns will be oriented such that all of them will focus on the pixel, and the combination of the content of R, the content of G and the content of B will give you the right type of color. That is for CRT based displays. Now we don't have the CRT based displays, we have got these LCDs or the LEDs. In those cases you will find there is electronic circuits, very small electronic circuits, which will light up the pixel based on the content of R, based on the content of G and the based on the content of B actually. So this is all now accomplished through the electronic circuitry, each one dedicated for the primary color. So you will find the graphics is monochrome or the color graphics.